In order to complete this lab or to compare to what we find in the literature on water hardness or on the internet, we need to do some unit conversions. So earlier in the semester we talked a little bit about solution concentration units, and we've been using molarity for most of our calculations so far. But we need to talk about parts per million now and how to get back and forth between parts per million and molarity. So parts per million is another concentration unit that's set up as a fraction, a mass fraction of amount of solute over amount of solution. So this is similar to molarity in that case. In particular, parts per million is saying you've got 1 gram of solute for every 1 million grams of solution. And we can convert the grams of solution to liters of solution if we think about the solvent being water, and the density of water is 1 kilogram per liter. So if we have a sufficiently dilute solution that we're talking about parts per million units, then the density of the solution is the density of water, and we can use that density to get to this representation, which is 1 gram of solute for every 1,000 liters. And then we can just step that down by 3 orders of magnitude to say 1 gram. If I take that to 1 milligram of solute, then that will be out of 1 liter of solution. So again, this is 3 orders of magnitude to get to the base, another 3 orders of magnitude to get from the base to liters. So that's 6 orders of magnitude difference, or 1 in a million. So these 3 statements are equivalent here. Now, if you have a solution that's 50 parts per million, what that means is you have 50 milligrams of solute for every 1 liter of solution. So whenever you read that parts per million, you can put that into, SI base units as milligrams of solute per liter of solution. Now, water hardness is given in parts per million of calcium carbonate in solution. We in lab will be measuring the concentration of calcium ions, probably in molarity, and so we need to convert the parts per million of calcium carbonate into parts per million of calcium ions. And so the question might be, what is the concentration of calcium ions in parts per million if the water sample is 50 parts per million calcium carbonate? Well, first, our strategy here is going to be to determine the mass of calcium present for every mole of calcium carbonate, or the mass percent. And then we're going to use that mass percent as a conversion factor to determine the mass of calcium 2+ in our 50 parts per million calcium carbonate. So to find the mass percent, we have here the mass percent of calcium in calcium carbonate would be the mass of calcium per the mass of calcium carbonate times 100%. So in this step 1, to find the mass percent, we look at the stoichiometry of the molecule itself. So if you just look at the subscripts for each one of these atoms, we can see that there's 1 calcium atom for every calcium carbonate unit. Okay, so that would mean there's 1 mole of calcium atoms for every 1 mole of calcium carbonate. And so we just need to find the molar mass of calcium and the molar mass of calcium carbonate to plug into this mass percent equation. So the molar mass of calcium, we can find that on the periodic table. It's 40.08 grams per mole. The molar mass of calcium carbonate, we can add up from the periodic table as calcium plus carbon plus 3 oxygens, right? Those are the masses of each of those. Add those up to get 100.09 grams per mole. So we plug those numbers, the mass of calcium per the mass of calcium carbonate times 100%, and we get 40%. The mass of calcium carbonate is 40% due to calcium. So in step 2, we can use this mass percent as well as the parts per million that we started with to determine the concentration of calcium ions in parts per million. So 50 milligrams of solute, we said if we had 50 parts per million, we had 50 milligrams of solute. We now know that that solute is calcium carbonate. So we have 50 milligrams of calcium carbonate per liter of solution. That's going to go in the denominator of my mass percent calculation. Okay, now we can plug in our mass percent from step 1 and determine the mass of calcium. Okay, so here's my mass percent of calcium in calcium carbonate from step 1. I have my 50 milligrams of calcium carbonate from the measurement that I'm trying to convert, 50 parts per million, and now I'm going to solve for the mass of calcium. So I divide both sides by 100%, I multiply both sides by 50 milligrams, okay, and that will give me 20 milligrams of calcium ions, or calcium in general, calcium atoms. So 20 parts per million is 20 milligrams of calcium for every 1 liter of solution. So that's exactly how we get from the 50 parts per million of calcium carbonate to 20 parts per million of just calcium. Now, to convert this back and forth to molarity, we need to recall that molarity is also a unit of concentration that's set up the same way. So we have amount of solute over amount of solution. And in particular, instead of grams or milligrams of solute, we're given here as a moles of solute over liters of solution. So parts per million was a milligrams of solute over liter of solution, and molarity is moles of solute over liters of solution. So our denominator is actually the same here, and we just need to convert our numerator from a milligrams of solute into a moles of solute. So if I start with 20 milligrams of calcium in 1 liter of solution, I can just use the molar mass of calcium to get back and forth between grams and moles. So here's my molar mass, grams per mole for calcium. And then we need to make sure that our units work out. This is in milligrams and this is in grams. So we need a factor of 1,000 here to cancel milligrams and cancel grams, so we get moles. So our unit conversion, metric conversion here from grams to milligrams is going to cancel my grams units here. My milligrams are going to cancel. I'm going to end up with moles of calcium over 1 liter solution. So there's my concentration of calcium in molarity if I have a 20 part per million calcium solution or a 50 part per million calcium carbonate solution.